Hi, my name's Chris and welcome to my benchtop micro shop. Welcome back to my benchtop basics series. Today's video is all about the table saw. A table saw is used to make straight, accurate, and repeatable cuts in a variety of materials. With the right setups, it's great for cutting large panels, from plywood, long straight rip cuts down the length of a board, or even the small square or angled parts. Next, I'm going to go over all of the basic components that you can find on just about any type of table saw. The first component of the table saw is the tabletop. It's called a table saw, or it gets its name because of its flat, smooth surface used for supporting workpieces. The second component of the table saw is called the side extensions, or wings. They're used to support material. The width of the wings determines the width of material you can completely support by the tabletop. You can build your own extensions. Some have router inserts. Some may move or adjust like mine does, especially on job site or benchtop saws that are designed to pack up into a small size for transportation. Item number 3 on the saw are miter slots. Most saws have 2 miter slots, one on either side of the blade. Because these are a fixture in the tabletop, you adjust everything to be square with the miter slots because they cannot be moved. The next item and first accessory for the table saw is called the rib fence. All fences should be aligned and adjusted parallel to the miter slots, and the blade should also be parallel to the miter slots. All fences come with some form of adjustment and clamping mechanism, and generally they have a scale that allows you to determine a preset distance for rip cuts away from the blade. How wide or far away from the blade the fence can be adjusted from the blade governs the rip capacity for a given table saw. You can always purchase aftermarket fences that allow for a larger table and greater rip capacity for your saw. Next, we'll talk about the blade guard assembly. A good guard will prevent you from coming close enough to contact the blade without obstructing view of the blade or cuts. The more functional the guard is in varying situations, the more likely it is to remain in place, not be removed by the user, and ultimately prevent accidents. Let's look at the guard mechanism on this saw in detail. This first component right here is called the riving knife. It keeps the kerf from closing back on the blade and pinching or binding, which can cause kickback. It also prevents parts clearing the blade from rotating back into the blade, which can also cause kickback. The second component of this guard assembly is the anti-kickback paws. Anti-kickback paws have spring-loaded teeth that ratchet on a board to prevent it from being pulled back through the blade if the cut were to happen to bind or pinch. Next, we'll remove the guard assembly and look at the inner workings of the saw. The next component is called the throat plate or insert plate. It's a removable plate that allows access to the blade but still supports material as it passes through the blade. Stock plates allow you to adjust blade angles and height through all of the stock settings of the saw. You can also make or purchase custom throat plates for situations like a zero clearance insert, which better improves the cut quality by preventing tear out, a custom angle, or a dado. The next component we'll look at is called the arbor and the carriage. The arbor is the mount shaft where the blade attaches. The length or width of the shaft governs the width of the largest dado blade that you can use. You see here I have an extra 1/2 inch of material on mine. The mount can be adjusted in relation to the table to ensure the blade is square with the miter slots. The motor will also be in some way fixed to this assembly, and job site saws often have the motor directly integrated, and most cabinet saws have a movable mount for the motor with a belt drive to transfer power to the arbor. Next, we'll look at the arbor nut, which is this component right here. All have some form of washer to go against the blade, and often arbor nuts are left-handed threaded so that the nut doesn't loosen with the counterclockwise rotation of the blade and arbor. Be aware of this when changing your blade. This saw is equipped with an arbor lock, which fixes the arbor in place when you need to break loose the arbor nut. My arbor nut is standard threaded and not counterclockwise. Turning it to the left or counterclockwise loosens it, and turning it to the right or clockwise tightens it. When many saws, the opposite is true. For saws that are not equipped with an arbor lock, you often have to place a block of wood in and under a tooth of the blade when breaking loose the arbor nut to change the saw blade. Next, I'd like to go through the pillars and trunions. Pillars are vertical shafts or bearings that keep the blade square as you raise and lower it through its stock settings. Trunions are angular supports or bearings that allow the blade to rotate through its angular settings. All saws have some form of adjustment wheel or wheels for lowering and raising of the blade and adjusting the angle. My saw only has one wheel and a locking mechanism for angular adjustment of the blade. Many will have a hand wheel for both raising the blade and on the side for angular adjustment. These mechanisms and their threads should be brushed from time to time to remove fine dust and chips, and greased or waxed to allow them to move smoothly. Every saw will have some form of base or cabinet which provides support to the table and the entirety of the saw. Virtually all saws have some form of a dust port and shroud that encompasses the blade and projects the dust out toward an extractor or collector source. Because the rotation of a table saw blade is down and into the table, primarily dust is pulled in the gullets of the teeth down and out through the dust port or thrown down below the saw. The power switch for the saw. On this saw, it rotates up for on and down for off. This should be readily accessible to the operator and in a position where you can shut it off quickly in case of an emergency. Next, I'd like to go over the miter gauge. This accessory rides in the miter slots on either side of the blade and allows you to guide crosscut material through the saw. Miter gauges adjust for angles and allow you to crosscut different angles. Next and final accessory I'd like to go over are push sticks. This essential accessory comes in varying sizes and shapes and prevents your hands from ever coming close to the blade during cuts. These can all be shop made. I prefer to use varying types for different operations to ensure I'm in control of the material in accordance with the type of cut I'm trying to make. Thanks for watching. I hope you enjoyed this video and learned something about the components of a table saw. My next video in this series is going to cover the two basic types of cuts for the table saw and how to set them up and execute them safely. Thanks for watching.